Good day, everyone. I'm Harris Badwa, and I'll be discussing CALENG2 for long quiz number 2. Now, this long quiz will comprise of the following topics, which includes integration by parts, trigonometric integrals, trigonometric substitution, rationalizing substitution, rational functions, and improper integrals. Now, as a short review, we'll briefly discuss about these following topics. These are the topics that is included for the second long exam. Now, for integration by parts, it is usually represented by this formula, which is the integral of u dv equals uv minus the integral of v du. Now, for trigonometric integrals, we have what we call the reduction formula, which is represented by the integral of x raised to n e raised to n dx equals x raised to n e raised to x minus n times the integral of x raised to n minus 1 e raised to x dx. Now, for trigonometric substitution, we have three cases. The first case is a squared minus u squared, which is equal to a cosine theta. And for this case, we have u, which is equal to a sine theta. For the second case, we have a squared minus u squared, which is equal to a secant theta. And the value of u here is equal to a tangent theta. For the third case, we have the square root of u squared minus a squared. And the value of this one is actually equal to positive or negative a tangent theta. Now, it is positive if the value of u is greater than a. It will be negative if the value of u is less than the value of negative a. And the value of u here is equal to a secant theta. For rationalizing substitution, we'll use x is equal to z raised to n, where n is the LCM or the least common multiple of the index of radicals or the denominator of a fractional exponent. Now, for rational functions, we'll be utilizing one of the lessons from FND Math, which is partial fraction decomposition or PFD. And for improper integrals, it discusses about the infinite limits and infinite discontinuity. Discontinuity. Now we'll proceed with our first example. For the first one, we have to find the value or the integral of dx x squared times the square root of 16 minus x squared. Now, at first glance, this problem, it is actually easy to identify what case we will use. Now, in the denominator, we can see that this one actually looks like this form, which is the square root of a squared minus u squared, where a is equal to 4 since the square root of 16 is 4, and u is equal to x. Now that we have the value for a and u, we can actually write du. Or first we will write u. For the value of u when using this case is actually equal to a sine theta, in which we know that a is actually equal to 4. Let me just write 4 here. And we need to find the derivative of du. So we'll find the value of du equals the value of dx is equal to 4 cosine theta. Now, for the square root of a squared minus u squared, it is equal to a cosine theta or 4 cosine theta. Actually, for this one, for du, don't forget that this has d theta beside it, since we derived the value with respect to the angle. And now that we have the values, we can substitute these values into this form. So we have the integral of dx. The value of our dx is 4 cosine theta d theta all over x squared. Our x squared is actually equal to 4 sine theta quantity squared. And the value of this one is equal to 4 cosine theta. At first glance, we will know that we can cancel 4 cosine theta, which leaves us the integral of d theta over 16 sine squared theta. We can take out the constant, which leaves us with d theta over sine squared theta. Now, sine squared theta, or 1 over sine squared theta, is equal to cosecant squared theta. So we can rewrite it again as CSC squared theta d theta. And we'll know from the review of the derivatives of trigonometric functions that cosecant theta is equal to negative cotangent theta. Since this one is positive, it means that our cotangent will be negative. And therefore, that value is equal to 1 over 16. Let me write it again. 16 times cotangent or negative cotangent theta. Now for this one, this won't be our final answer, since our original function, the variable is equal to x. Therefore, our final answer should also be equal to x, or represent x as our variable. Now we have to draw a right triangle to find out the value for cotangent theta. Remember that when the form is square root of a squared minus u squared, it means that it is on the bottom side of the angle, or it is the adjacent angle, which is beside the theta, which means this is our u. This is our u, and our hypotenuse is equal to a. Now to find the cotangent theta, it is adjacent over the opposite. So let's write down here that cosine theta is equal to adjacent, which is the square root of a squared minus u squared over u. Or we can rewrite it as the square root of 16 minus x squared over x. And this is the value. This is letter T. This is the value that we will substitute here to have our final answer. And once we substitute it, let's write down here 1 over 16 times write it more legibly. Negative 16, since that's what it says, over x plus c, which means that our final answer for this problem is equal to negative the negative square root of 16 minus x squared all over 16x plus c. Don't forget the c. That is the answer to our first problem. Now let's proceed to our second problem. And our second problem will be a definite integral, which our upper limit is pi over 2 and our lower limit is 0. And our function is secant raised to 4 x dx. Now at first glance, it is hard to discern what to do with here. But since it is raised to 4, we can actually expand this function into secant squared x times secant squared x dx. And using the trigonometric identity, we can rewrite it again as secant squared x times tangent squared x plus 1 dx. And we can just distribute secant squared x. This will become secant squared x tangent squared x plus secant squared x quantity dx. We can separate these two terms now. So we have pi over 2, 0. So it becomes secant squared x tangent squared x dx plus of 2, 0, secant squared x dx. Now for this one, for the first term, we can actually use this formula. We can use this formula, u raised to n du, in which our u is equal to tangent x, which means our du is equal to secant squared x dx, which is here. Which means that the first term is equal to u2 du and will now be equal to u3 u cube over cube c. And now for the first term, we can just substitute the value for u for this one. Won't have the integral sign anymore. Which means this will become tangent cube x over 3. Still have to plug in these values later. Plus, as similar to what we discussed earlier, secant squared x, however this one is secant, this is actually equal to tangent x. Still have to put this one. 2, 0. This one is equal to 2. There. And now, at first glance, the next step should be substituting these values and subtracting the value with this one as the value. Like for example, it will become the tangent cube of pi over 2 over all over 3 minus the tangent cube of 0 all over 3. However, if we put it in our calculator, tangent pi over 2 is actually undefined. So when we encounter a problem like this, we can identify it as an improper integral, which means that we have to use limits to solve this function. So we have to use this. The limit as x approaches pi over 2 of tangent cube x 3 pi over 2 0 plus the limit x of tan x from pi over 2 to 0. For this one, when the value approaches pi over 2, it is actually equal to infinity, which means the value of this one will become infinity over 3, which is still equal to infinity or a really, really big number. And when we substitute the value of 0 to tangent x, it is still equal to 0. So for here, we'll just subtract 0 from infinity. Next is plus. The similar case happens to this one. This is also infinity minus 0, which means that the integral is equal to 0, is equal to infinity, which means that the integral diverges. Once again, this is Harris from Syntax, paving your way to excellence.